nice piece of functionality we have is to look now at all the different forms and punches and see what the overall pressures are. So here I just adjusted it to tons. We can zoom up on each one of those punches, and this gives us an idea of what it's actually going to take to stamp this strip. And this is a very handy tool of finding out what the die tip is and making sure that there's a good balance from left to right, end to end. So now we're ready to go into our tool design wizard. So I'll just switch over to that particular wizard. And let's go and get a die set. Now this is our first glimpse at what we have inside of the catalogs. The catalogs can be catalogs that would come from a supplier, like you see here, your Danley and Dayton catalogs, your Missimi catalogs. This is an ongoing list all the time as we're having more and more catalogs being added to it. Some of these are custom for just our specific needs of a customer or things that can be shared. Also, you see we have different components. We could have assemblies as catalogs, a rocker assembly, a cam pierce unit, in this case a die set. So the entire die set is going to be loaded here through our catalog. It's just a matter now of having the configuration the way we want it. So it would be the way you do your dies. Everybody may have dies that they do a little differently. I'm going to tell it that I just simply want to position this particular die set right here at the beginning edge of the strip. And as it loads, it sizes itself per the strip. Alright, so the die steel width that you see is established by the width of the strip. And then from there, the rest of the components are sized based upon simple rules. Like there's a gap between my material guide and my stripper, and that stripper plate is big enough to cover the width of the strip. Likewise, distance away that establishes the overall size of the die. You notice here I'm using a formula to establish the overall length, which I gather here back in our setup. Pull downs can be created in a setup to establish the different thicknesses that we commonly use per each plate. As I make changes, here I'm changing the length of one of the die steels, and as it updates, you notice that other things linked to it update. So if I'm going to change the length of the die steel, it makes sense I change the length of the material guide. If I change the length of the retainer plate from punch retainer, then I'd also change the length of the stripper plate. So these simple common rules can be established and used throughout the setup, making things a lot easier to adjust, very customizable. The use of rules, use of pull downs, automatic rounding up, rounding down. Also we have the ability to pull our sizes directly from a catalog. So perhaps if I put in my Danley bushings, I can go right to that catalog size and adjust it as I need to. Well, with that, we've adjusted the size of our steels that you see here. And now I'm just going to turn the punch off, and you can see the strip lying nicely on top of the die steel. Right. So what we're going to do now are pull all the punches. And like I said before, you can use the punch geometry and mirror it, rotate it 180 degrees if it's going to be used again and again. That's fine. But for what we're doing here and to illustrate this functionality, we'll use all those punches that we have on the strip, and in one operation we'll create these punches and all the holes that they sit in. So focusing here on the wire EDM punches. As I accept this, it begins to preview and build them for me. Alright, so we'll turn the whole die set on. There you can see how it's extended now past the coil steel, so it shows me what my shear distance is going to be through that coil. Alright. And as we build this, it'll build the pockets that it sits in on the punch side and also the clearances on the die side. Now originally, when we set up those clearances, the stock material guides were not there. So now let's establish what we want to cut around those, and then make any final adjustments that we need. Right. So as I highlight each of the different plates, you can see them highlight on the screen. Right. So it's all linked together, very intuitive, very fast and powerful. And now it goes ahead and builds the punches. It builds the holes that the punches sit in as well, both in the punch and the die side of the tool. A little bit hard to see, but it's there. Let's do a little dynamic clipping plane here, and we'll try to cut that so that we can land on one of those punches, and you can see the clearance now for the slug drop going through the die shoe. You can see on the die steel the land and then the 2 degrees of relief, and then you can see the fit in the punch retainer. So all that's done in one operation. All those punches can be edited together or individually, in your case. If I know that the punch on the right and the left are the same, I can detail one, but I've got all the holes I need in all the plates, which is an important thing. Alright, looking at the strip, you can see we got a forming area or two. Let's concentrate on one of these forming areas. With that, we'll go back into our catalog, and I'm going to pick here just a assembly. It has the screws and dowels already placed in my die steel, so I'm placing more than one component at a time, which is very handy. And like I said, those units could be punch units, they could be cam pierce units, rocker assemblies, it's whatever you want to assemble together. We'll position that steel to capture that particular station, and I'm going to tell it that I want to grab the information that I've got here right off the strip. So I'm working on the die side, creating a piece of die steel that's going to form that station for me. A lot on the screen, so let's just open up that individual component now. Everything is still there, I'm just looking at one part. Makes it much more easier to work with. Alright. Blanking off the steel, we can work with what we're going to cut it back by. Here I'm just going to simplify my shape a bit. Alright, so we don't need those faces surrounding us. And what we'll do is now extend this outer edge all the way around like you see here. So I capture that edge, use my extension tool, something plenty big enough that will get out past the outside of my block. Now let's do along this other edge. We'll simply chain from side to side. You notice there's a little notch left in there. As I sweep that face out, which is basically like a big ruled face, you notice it doesn't care about the notch. So I just simply make it big enough that the notch is off the side of the block, it becomes irrelevant. And you even see it do that with the areas that are undercut, if you can imagine that. So basically it's giving me a flat, planar face as my solution. Now we'll simply take the block and trim it back by those extended faces. Alright. Pick which side of the block I want to keep. You notice I didn't close the inside, so it doesn't have to be perfect airtight. I do want to close that because that's part of my form, but nothing keeps me from proceeding if things aren't done in any set particular order. It's up to me to do it how I want to do it. And with that, let's show some of the tools we have for closing up these little gap areas. Maybe I want to grab that edge and say I want to blend across to the other side. And it's such a powerful function that keeps things tangent to tangent. It knows the flow, it works with the flow of the face. Again, we'll do the opposite side. Alright, now we'll tell the system, let's stitch those together. I've got the 3 holes left, 2 on the side, 1 in the middle. And let's use a nice tool called close open gaps. We just simply pick or box pick the areas that we want to close. It's more than one face in each of those holes. It goes and puts in its solution as quickly as it can. So that particular form area is now closed. I save it, and when I do that it bounces me back out to my assembly. Alright, there you see that now we have a little bit of work to do, because with the cut those screws are not in the right position, and frankly they don't look to me like they're big enough. So let's do a quick edit here. We'll edit the screw parameters. Let's make it bigger while we're at it. So it's just a matter of going into the catalog, selecting the size, selecting the length we want, like you see here. Say that looks good, and you'll notice that quickly on the screen it's changed. Let's now drop that in. We'll recess it a little deeper. You can recess things based upon rules. Here I'm just dropping it in so that I know it's deep enough within the steel. Now as we calculate it, you'll see it also updates the hole that sits in it. So there you see the counter bore on the opposite side has been drilled and tapped. Let's flip over down to the other side and give our attention to the punch and talk a little bit more about the catalogs. Here in this particular case, I want to use the catalogs to put my pilot punches in. So those are going to sit in the retainer plate. I'll simply hop on over into our catalog. There I'm picking just a straightforward pilot punch. To do a little bit more work so you can see how easy it is to edit this. Of course, with the pilots, you're picking your diameter, your body diameter, the overall length, and then the p-value. So all that is established based upon whatever type of catalog you're using. Here I'm using a TIPCO catalog. Could just as well be a Dayton catalog, you name it. Alright, so we're working off the back of our retainer plate, and I'm using the locations right off of the strip. So that's where the first one went. That's the next one, and on down the line. Alright, so do I like the length? Do I like the positioning? Well, I can see that my shoulder's coming up into the strip. So let's go back, do another quick edit here on the fly. Maybe in this case I'm going to change the length a little bit. Alright, so we select a shorter length, and also while I'm at it, maybe I want to put a little bit of clearance on that p-value so that the pilot slips in and out fairly easily. Alright, that looks better. We'll cut it as we build it so it knows the hole that it sits in as well, as you see by the counterboard.